a brain cancer that has remained nearly impossible to treat, a deadly virus that can disguise itself as the flu, and a flesh-eating parasite that was eradicated from the United States decades ago. Each presents a different challenge, but in every case, engineers are developing new tools to detect, track, and fight back. So, how far can engineering go when nature refuses to cooperate? Hello, Circuiteers! Nature can be a source of inspiration. It can also be a source of some of humanity's toughest problems. Today we're looking at three very different stories where engineering is helping researchers understand disease, improve treatment, and stop biological threats before they even spread. When 20-year-old University of Michigan student Ethan White suddenly forgot how to use the drumsticks he had used for years, doctors discovered a tumor deep inside his brain. The diagnosis was diffuse midline glioma, or DMG, a cancer that grows in parts of the brain that are the most dangerous and challenging to operate on. Primarily affecting children and young adults, the median survival rate for those diagnosed with DMG is between 9 to 11 months. So for many, a DMG diagnosis is a death sentence. But engineers and scientists searching for new approaches found inspiration in an unlikely place: the firefly. Researchers inserted the same luciferase gene that makes fireflies light up into the trail gene, which is naturally produced by humans. The fusion of trail and luciferase became a biological flashlight, making cancer cells glow. This gave researchers the ability to track how trail-armed cells moved through the body, helping engineers and scientists better understand how to target aggressive brain tumors. Those insights contributed to decades of research that ultimately led to the development of Modeyso, the first FDA-approved oral once-weekly therapy to change the standard of care for DMG patients. Once Ethan White started taking Modeyso, this science and engineering breakthrough allowed him to graduate from college, rock climb, and continue to live a largely normal life after his DMG diagnosis. But while engineers and scientists can learn from nature, they also have to protect us from it. And some threats are nearly impossible to recognize before they become deadly. Earlier this year, Dutch expedition cruise ship MV Hondius made international headlines when a severe hantavirus outbreak occurred. Hantavirus is spread to humans through contact with the saliva, urine, or droppings of wild rodents and has a mortality rate between 20 and 40%. Oftentimes, hantavirus symptoms look identical to the flu, but can progress to severe respiratory failure by the time doctors realize what a patient is actually suffering from. This year, engineers and researchers used the codeAj Hantavirus risk assessment module to screen 50,000 blood tests. The AI module caught 3 hantavirus cases missed by doctors. Engineers have helped develop other hantavirus AI platforms, which use computer vision models to identify high-risk rodent species with 85% accuracy just from uploaded photos. Of course, some biological threats aren't thwarted by AI, but by nature itself, with the help of engineers. The New World screwworm fly was eradicated from the United States in the 1960s, but recent cases in Texas have renewed concerns about its return. The New World screwworm may look like an ordinary fly, but its larvae are anything but ordinary. The larvae from ordinary flies feed on dead tissue. The larvae from screwworm flies feed only on living flesh. That means the screwworm fly can create severe wounds that can kill livestock if left untreated. So, to stop the spread, the U.S. Army Corps of Engineers came up with a multi-million-dollar engineering solution. They partnered with Mortensen Construction to build a new sterile fly production facility at Moore Air Base in Edinburgh, Texas. Once fully operational, the facility will produce 300 million sterile flies a week to combat the New World screwworm fly. Female screwworm flies only mate once, so when they mate with a sterile male, the females will lay unfertilized eggs, ultimately collapsing the wild population. The USDA says that the new state-of-the-art facility will provide the speed, scale, and domestic capability needed to rapidly counter any NWS threats, protecting animal health and strengthening the resilience of America's livestock industry. So, how far can engineering go when nature refuses to cooperate? As far as an engineer's imagination can take it. You see, these stories show that engineering isn't just about building technology. It's about borrowing from nature, decoding its mysteries, and building the tools to protect us from its greatest threats, however small they may be. And if you enjoyed this week's episode of The Circuit News, don't forget to like, subscribe, and click those bell notifications for more incredible engineering. See you next week. And a special thank you to the Ming Hsieh Institute at USC Viterbi for making this episode possible.